Let's take a look at the empirical rule and a couple of examples of how to apply the rule. The empirical rule works only if your distribution is roughly bell-shaped. It says that approximately 68% of the data will lie within one standard deviation of the mean. That is, approximately 68% of the data will lie between mu minus 1 sigma and mu plus 1 sigma. Approximately 95% will lie within 2 standard deviations of the mean, and 99.7% within 3 standard deviations of the mean. Now, if we look at a normal distribution, because of the symmetry of the curve about the mean here we've got mu, and if we go up mu plus 1 and down mu plus 1, we've got 68% based on the empirical rule that falls in between these boundaries. So that puts 34% on each side because of the symmetry. Now, if we go down 2 standard deviations and up 2 standard deviations, some of this didn't print well, we will find that we've got 95% between here. So 95 minus 68 split in half gives us 13.5% in each of these sections. If we go down 3 standard deviations and up 3 standard deviations, the rule tells us that 99.7% falls in this span. If we take 99.7% and we subtract 95% and split it in half, we've got 2.35% in each of the sections. Now, the entire area under the curve is 1. So if we say 99.7 subtracted from 100%, split it in half, it leaves us 0.15% in the two tails. Now, basically, there are 2 applications of the empirical rule at this stage, and this rule will make a lot more sense as we move through the remaining chapters in the text. But if we look at this example, there are 2 different ways we can use this. One, we can use it to construct the intervals, or 2, we can use it to tell what percentage is going to fall with our specific values there. So if we look at our first example, and if I draw my normal distribution here, it's not very pretty, but it'll work. We've got 100 is the mean. So if I go up 1 standard deviation, which is 16, I've got 116. Go up a standard deviation, I've got 132. Go up 1 more standard deviation, I've got 148. If I go down 1 standard deviation, I will have 84. Go down another standard deviation, so I'm just subtracting 16 each time, I will get 68. Go down another standard deviation, and I get 52. Alright, so let's look at our problem here. It says, what percentage of people has an IQ score between 68 and 132? So between 68 and 132, that's the 2 standard deviation mark, so we will have 95% of the people will have IQs between those 2 values for this particular IQ test. What percentage of people has an IQ less than 52 or greater than 148? So less than 52, we're looking at this region. Greater than 148, we're looking at this region. Well, these were our external tails over here. So that was 0.15% fell here, 0.15% fell here. So if we add the 2 together, we've got 0.30%. What percentage of people has an IQ score greater than 116? Well, if we look at our values from our table here, greater than 116 is going to be all of this span of the curve. So that's 2.35%, 13.5%. So if we add those up, we've got 13.5%, 2.35%, and 0.15%. That gives me 10, 8, 9, 10, 3, 4, 5, 6. And 1. So 16% will fall above that. So let's see, 13, 14, 15, 30, 40, 55, 50, 60, 70, 80, 90. Yes. Okay, so 16%. All right, another example of how we could work this problem. Let's look at another one here. We can set up our distribution. A lot of times this will be referred to as the 68, 95, 99.7 rule, because if we learn those values, 68, 95, and 99.7, then we could construct this table at any point we need. So it's the 68.599.7. Alright, with our data here, it says the weight of an organ in adult males has a bell-shaped distribution, which has to be true or we can't apply this rule, with a mean of 310 grams. Standard deviation of 35. So the standard deviation is 35. Alright, so if we just set up our table, if I go up 35, I'm at 345. Go up 2 standard deviations, I've got 380. 3 standard deviations, I'm at 415. Go back a standard deviation, so I'm subtracting the 35 now from the mean. 275. Subtract another one, I'm at 240, and one more puts me at 205. About 95% of organs will be between what? 95% was the 2 standard deviations above and below the mean. So 95% of the organs will be between 240 grams and 380 grams. What percentage of organs weighs between 205 and 415? So between 205 and 415, that will be our 99.7%. So let's just squeeze that in over here. 99.7%. What percentage of organs weigh less than 205 or more than 415? So that's our area here and here. So that was the 0.15% and the 0.15%. So for that one, we've got 0.30%. And then finally, what percentage of organs weigh between 240 grams and 415 grams? So between 240 and 415. All right, so if we took this half here, we're going to have all right, we've got 50 minus the 0.15 gives us 49.85%. This was 34%. And if we look at our table again, we have 13.5%. So 13.5%. So if we add that up, we've got 49.85, 34, and 13.5. So that's 5, 13, 10, 17, 7, 8, 9. So 97.35% fall between 240 grams and 415 grams. Once you have your table set up based on the empirical rule, all your values, then it's just a matter of looking at your curve and adding your percentages together. If you have any more questions on the empirical rule, please don't hesitate to contact me.